Let's take a look at another example. Suppose we have the following differential equation. Number 3. So for this differential equation, what do we have? We have the second derivative of y plus xy prime plus ln of x y equal to 0. So it's already written in standard form. So we look at the coefficients x and ln of x. We're not really worried about x. It's defined everywhere and it's analytic at every real number. However, for ln of x, we should be careful. The domain of ln of x is 0 to positive infinity. Ln of x is discontinuous at x equal to 0. So it cannot be represented by a power series. Since ln of x is not continuous at a given point like 0, so it cannot be represented by a power series. So at this point, it's not going to be analytic. At x equal to 0, we have a singular point. Let's take a look at another example. Example number 4. We're still classifying. We have x, the second derivative of y, plus y prime plus xy equal to 0. First of all, we need to write this in standard form. The second derivative of y plus 1 over xy prime plus y is equal to 0. Well, the functions that you're dealing with are 1 over x, and the other one is just the coefficient of y, which is 1. We're not worried about this. But here we have 1 divided by x, the reciprocal function. The domain of this function is negative infinity to 0 union 0 to positive infinity. Well, at x equal to 0, we have discontinuity. So it means that it cannot be represented by a power series around this point. So x equal to 0 is a singular point. Later on, we're going to divide up the singular points into regular and irregular points. Another example. Example number 5. We have the following: x squared minus 1, the second derivative of y, plus 2xy prime plus 6y equal to 0. Since it's not written in standard form, we have to divide up everything by x squared minus 1. So we get the second derivative of y plus 2x, x squared minus 1, y prime plus 6 over x squared minus 1, y equal to 0. So the functions that we're dealing with are 2x over x squared minus 1 and 6 divided by x squared minus 1. As you can see, here we have a rational function, and the domain is going to be R, all real numbers minus the solutions of the denominator. Very well. So since we are excluding 1 and negative 1 from the domain, we have singular points at x equals to 1 and x equals to -1. This is the same for both of these two functions.